Welcome students. We are continuing from where we stopped last time. If you remember, last time we were discussing something about perfect squares. We are there trying to factorize expressions which are defined as perfect square. So from our discussion, we saw that expressions which are perfect squares are all expressions which have got identical factors. Factors are always the same. Like in the number system, where I can have 25, factorizing 25 gives me 5 by 5. Then we say 25 is the perfect square. The same if I can have this another expression here now in the expression, like 4x squared plus 4x plus 1. If you try to factorize that expression by the method we discussed previously, you'll be able to see that the factors of which are that's 2x plus 1 and 2x plus 1, which simply is just written as 2x plus 1 squared. Then we say this expression 4x squared plus 4x plus 1 is a perfect square. So today's business is just a matter of trying to complete the square of other expressions. Simply to mean that in expression, quadratic expressions, there are some expressions which are not perfect squares. Some are perfect squares, like this one here. So if an expression is not a perfect square, we can really find mechanisms of making them as perfect square. So that is the discussion of today. For example, on the board here, if can we try to factorize it, as we have already started. Let me just first of all talk of the sum from what I've just said here. To say if I can factorize 4x squared plus 4x plus 1, you'd be able to see that the factors of which are, by that grouping method of factorization, we are obtaining these factors here, which are 2x plus 1 and then 2x plus 1. Identical factors indeed, meaning that this is a complete perfect square. It's really complete and it's a perfect. But now on the other hand, I may have another quadratic expression which has got two terms. Usually we call such expressions as binomials. And if I can try to factorize it, look at this one here, x squared plus 4x. That is also a quadratic expression. To factorize this one is simple. We can use those mechanisms we have been doing in Form 1, whereby we factorize this one by just dividing by the common factor. It won't go by the grouping method we discussed. So here you just identify what common factor goes into the two terms here, and you do that, the division of which. So for this term, the quadratic term, and 4x here, you'd observe that the common factor that can get into the two is x. So you write x like that. So when x gets into x squared, you open a bracket like that, gets x. And this x gets into 4x, that is just a 4. Right, what does this mean? This one simply means that when I can go back to the previous expression, it'll be just a matter of expanding this expression here. Where it'll be just like x multiplied by x, I get x squared, x multiplied by 4, I go for x. Which means in this case, if I look at x alone and x plus 4, these are just defined as two factors of this one. So which means when I'm to factorize this x squared plus 4x, I get x and x plus 4. Let us now compare this expression and this expression. The factors of this are this and this. If you look at these two factors, is 2x plus 1 and 2x plus 1. These two factors are identical. Then we define this one as a perfect square. It's a complete one, really a complete perfect square. But now if you can look at this expression here, after factorization, what we're getting here just x, and this one is x plus 4. You can really see that the two factors are different. This is just x, a single term factor, but this one is x plus 4, which is a two-term factor. So which means this one is different from this. Hence, this one is not a perfect square. Our discussion now is simply to complete the square of some expressions which are like this one. So it's more like what can we do to make such expressions as perfect square to be expressions like this one here, where at the end, after factorization, we should be able to obtain two factors which are identical like that. So our discussion will be just by completing of the square of the quadratic expressions which are not perfect squares. Right, so students, can you stay tuned? And now here we're going to discuss how we can complete the square of quadratic expressions. Right? Right, now before I dash down the example that I would like to use in order to complete up the square, let us first of all try to understand what we're going to do in here. Right, so for example, let's look at the number system, whereby when we say a number is a perfect square, from what I studied up here, I gave an example of 25 being it as 5 times 5 in factor form. This gives us 25, then we call 25 as a perfect square. Now here I have another number like what? 12. Then if I look at 12, in 12 there are no identical factors like in the 25 we have got factors 5 times 5. So really if you look at 12, you can really describe it not as a perfect square, right? Because there are no identical factors like the ones we have in what? 25. So now the question will be this: how can we make 12 as a perfect square? Because the way it is here, it tells us 12 is not complete, right? So how you can make this 12 as a perfect square is only by considering another term that can be added to it. So like here, if I may ask you, student, to say, what do you think we can do to 12 in order to make the perfect square? You may be able to tell me, to 12 there, we should at least add a certain number. Then that, it will be a perfect square. So like here in this case, you have 12. What do you think we can add to 12 to make a perfect square? So you'll be able to see that when you analyze this one down, you'll be able to see that 12 can be added by a number which is a 4. Right. So if 4 is added to 12, what we get is what? 16. And now the result is what? A perfect square. So the same way we have done with the 12 here, which is not a perfect square, but we have managed to add a certain number to 12, which is a 4, and give us 16, then 16 as a result is defined as a perfect square. It is the same way we need also to consider, expressions, quadratic expressions which are perfect square. So simply what we are going to do in this example are just like a amount of trying to find a term or else a talk of a number in this case that can be added to a particular expression so that that must be a perfect square. Right, so allow me now to write the example of which will be done based on what I've just written on the board. What must be added to the following to make the results a perfect square? I have got a y squared plus 4y. B, I have m squared minus 7m. Right. So here we are. Let's use this space here. All right. So if I may ask you to factorize the first one, you're really going to observe that here the result will be two factors which are identical at all, are not identical at all. The same it applies to example B, which means this is not a perfect square. This again is not a perfect square. So like what we have done with the 12, we added a certain number. So it's just like here, for us to make this one as a perfect square, what can be added to this one? So that at the end, when I factorize, I have to obtain factors which are identical. Right, so please, can you stay tuned and try to listen to me and follow me very well about the procedures that we use in order to come up with a term to be added to such expressions in order to make them as perfect square. Right. Right, so here I've got example A, which is y squared plus 4y. So the whole process is just like this is lacking a term that can be added to it in order to make the result a perfect square. So mathematically, we are going to show that one out that say this is incomplete. So we really need to have y squared plus 4y then plus a question mark. What is there now on the question mark? So that the result should be a perfect square. Right. To come up with a term that can be added to these two terms here, remember this is the original one, you need to follow the following procedure. Look at the original expression. We have got this one as a quadratic term, but the other term is non-quadratic. We said earlier that the quadratic term is just a term which has power 2 as one of its variable. So now you look at the two terms here, a quadratic and non-quadratic. So what you do here, you are going to tamper with a term which is non-quadratic out of the two. So how are you going to tamper with that one out? So this is what you're going to do here. Y squared plus 4y plus. What you do to here, to this term here, is what has to be added here or being substituted. For what? That's the question mark. Here for this non-quadratic term, you look for the coefficient of which line. So in this case, the coefficient of y, which is the which in this case, variable y is a 4. So we are just looking at the coefficient of a variable of that term. So the variable of this term is y. What the coefficient in this case is 4. So that 4 you get is the one you're going to at least add it there. But you not just add the whole 4 as it is. But that 4 has to be divided by 2. Or simply means it has to be multiplied by half. So what I'm trying to emphasize is just like you always have to consider a non-quadratic term and out of which can you just obtain the coefficient of that variable, which in this case is y, is the one that has to be halved. So after you have halved that one, then you remember to square the result. So this is what we're going to do here. So now I'm getting a 4 here, dividing by 2, and after I square it in attempt to find what can be added here to make the result as a perfect square. So here to go like y squared plus 4y plus, here you have 2 into 4 gets 2 times, and then that has to be squared. And then what we get at the end is y squared plus 4y plus, here it means 2 times 2. So if you look at the 2 times 2 here, for the power 2 here, this one will give you a 4. So the result is just this expression here. Now if you can look at this expression, the lower like terms, so which means it's just like the expression in itself as it is. So as such, this is what we have here, the result from the 2 termed expression. Now here we have got what 3 termed expression. So you compare this one and the previous one, you see that the first one has got 2 terms, this one now has got 4 terms, has got 3 terms. So the third one, which has just come, has been added there. That is the number that must be added to this expression to make the perfect square. So here we're going to conclude and say, therefore, 4 must be added. Simple as that. So I give you just a task to you students, because I've already explained everything about factorization. You try to factorize this expression here. You try to factorize it out and see what factors you're going to obtain. You're really going to bear with me that the factors you get from this will be identical. And you're going just to get them like bracket by bracket, the same like a plus b, and after you just write it a plus b, then squared. So this is a perfect square. It's now complete. It was incomplete, now it's complete by adding a 4. Right. In example B, similarly, For this one, I think we're going to speed up with it. Right. Just push up talk of the procedure as explained by example 1. So in B here, where we have got m squared minus 7m, we'll do the same. We'll write m squared minus 7m plus a question mark. What should be there on the question mark? It's something that should be added to this expression to make the perfect square. So by the first explanation here in the first example, you'll be able to see that the area I was able to at least consider this term, which is non-quadratic. Out of the two, the coefficient of the variable m has to be the one has to be divided by 2 or has to be multiplied by half to get something like this, minus 7m. Here the coefficient now is negative 7. Here it was a positive 4. So I had to get the positive 4 right here. But now here I'll also write plus c. This is negative. I write negative 7 like that, then divided by a 2. Then that must be squared. So here it go like m squared minus 7m plus, and you write the 2 into negative 7m. That into negative 7, then that you take from there, it'll be what? That's a talk of sometimes you can just decide to write this one in the proper fraction instead of writing a decimal fraction. There's no problem there. Right. So say for example, as it is here, squaring this one without at least tampering it, forcing it to divide into negative 7. You can just simply square this one out. And what you obtain from there, it will be that is squaring the whole of this one simply means negative 7 over 2 multiplied by negative 7 over 2. No problem with that because it's squared. So that we have here, it will be m squared minus 7m plus negative 7 multiplied by negative 7, you have got 49. Then 2 multiplied by 2, you have got a 4. Think like that. If you wish, you can divide the 4 into 49, or you can leave it like that. So which means here again, if you compare what we have here now at large and what we had here earlier, you find that this is m, negative 7m, negative 7m. But after tampering this expression with all these processes here, we have found ourselves that we have got an additional term, which is 49 over 4. So which means now a third term in this case is the one that must be added to this one to make this a perfect square. So what we have here, we also put the same as to say, therefore, in this case, 49 over 4 must be added. Right. To make the expression as the perfect square. Right. Additionally, we may also have a little situation about the expression, which I need at least to give you one example, because you may take it for granted that sometimes you always go straight into dividing that's the coefficient of the variable y by what? By a 2 in this case, and also you're dividing by what? Talk of the 2, that's the coefficient of m in that case. Somewhere there can be sometimes a slight change that this process cannot sometimes work direct. So let's now see what are these such type of examples that may not directly work as we have it here, but that maybe we do something to them. Right, so here let us have example 2. Let's look at this. Right, number 2. Right, we also talk of the same kind of example but different expression. You say what must be added to the following to make the result a perfect square. Right, here I have got a 4x squared plus 12x, b 2y squared minus 7y. So what I'll do here, I'll just solve one. This other one will be like your exercise. So can you follow me? My procedure is just straightforward, or not all that difficult, like that you may not even need another example. That will just be your trial exercise. All right. If you compare this expression as I have it here that is the 4x squared plus 12x. And the first one, which we had like y squared, that's a plus 4y. You find that this expression and this expression, they differ in one form. The difference that we are interested upon here is not the variables, no, but coefficient of the quadratic term, which in this case is y squared, in this case is 4x squared. Coefficient of this one is 1 here, but coefficient of this one is a 4, different from a 1. So if we just go directly by dividing this 12 by a half, we find that at the end, we are not going to obtain the expression which will be what? A perfect square. If you try to factorize, find that that won't work. So here we are. What really should we do in order to make the result, after adding something there, to make the expression as a perfect square? So it's more like what are we now going to add? Apart from the procedure that we have been used, do you have a different thing? Like, so here what we will do is more like the first step to be taken should be a consideration of affecting this quadratic term first. The area 1 had the coefficient 1, and we're also going to make this quadratic term to also have a coefficient 1. So it's more like a must that always the coefficient of the quadratic term should be a 1. So what are we going to do? So here it means we're going to factor a 4 in this case. That 4 has to be removed in order that we should have a 1. So what you have is a 4 here. You divide the 4 throughout. 4 here is x squared. 4 here is plus 3x, like that. If it was maybe a number like 7, you would have first of all divided by 7. And what have you here? The coefficient of a variable for the quadratic term. So once you have done this, is when now we are going to focus with the expression inside the bracket. So what you do about this one is what we have already done previously. It's more like what we have already done previously. What did we do? What we are doing there was just like now I will not throw away the 4, but it still may be outside because it's part and parcel of the expression. So which means here I'll concentrate on x squared plus 3x. Then I'll still do the same. What should I add? It will be now consideration of the coefficient here of x of a nanny. That's a quadratic term. Like, so that one, which is the 3 in this case, has to be divided by 2. You square that, while outside you still have a bracket because we have got a 4 here, which was just factored out, but you cannot throw it away. So here we have our 4 going with it down like this, x squared plus 3x plus c, and we can allow this one here to leave it like that. You multiply just that one to say 3 over 2 squared. That will give us 9 over 4. That's what we get there. So which means what we have done here is only that the inside part has been made to be a perfect square, which is this one here. So if somebody were to ask you, can you make this one as a perfect square? What you do just the process inside here. So it means 9 over 4 must be added to this one. But now, considering the expression had a 4, so what we do is just like this 4 has to be now multiplied by everything inside the bracket. Remember factor of the 4, and thereafter we need also to multiply the 4 itself throughout the terms inside the bracket. So here it would be like 4 times x squared, you get 4x squared, and then 4 times 3x, you get, that's the 12x, and then 4 multiplied by 9 over 4, here you get, that's a 9 over 4 times the 4, which here you cancel 4 into 4, get a 1, here you have a 9. So as such, from that what we have just done, what we obtain is this kind of an expression. It will be 4x squared, then plus 12x, then there plus 9. So you can see here, we have this 4x squared, 4x squared, 12x, 12x. But now this one has got an additional term, which is a 9. Here it doesn't have anything. So which means it tells us to this one, we must add a 9. So in this case, it means if you can try to factorize this one by the method we discussed that time, you're really going to bear with me that the factors you obtain from here, they'll be identical. As such, you say 9 must be added. Right. So that's the way we do. So please, when you have this type of expression, you'd like to make them a perfect square, please first check what is the coefficient of the variable of the quadratic term. So that's what we have today. So for the example B, I'll just leave it to you. Try to make 2y squared minus 7y as a perfect square. Bye. Thank you very much for listening. Next time we meet, we'll look at this, how we can solve quadratic equation by completing of the square. Thank you.